Welcome to the MyProjectBazaar.com. Our title is Page A, Partition, our engine for parallel graph computation. And this project has the modified title, and the modified title has an efficient graph computation using BFS. A partition, our engine for parallel graph computation. In this modified abstract, we have to see what are the abstract has to be seen in this particles. And thus a graph partition quality affects the overall performance of parallel graph computation systems. A balanced graph partition with small edge cut ratio is generally preferred since it reduces the expensive network's communication cost. Many distributed computing applications are based on graph whose nodes and the edges correspond to the computation and communications. The systems handle the local messages and remote messages unequally and only optimize the processing of remote messages. The system apply the graph travels algorithm VFS techniques. When the graph is partitioned into subgraphs from source node to destination, each subgraph has a smaller size and hence overall performance will be improved with each worker having less workload. This is the modified abstract for the page partition our engine for parallel graph computation. This is the architecture diagram of the partition our engine for parallel graph computation. In this architecture diagram, we have to create the node creation. Just like that, we have to start the process and to create the node creations and node deployment using graph partition algorithm. In this algorithm, we have to generate a node root network. Generate a node root network, and also you select a source and destination node to transmit data, and select the data from different sources and data encryptions and send to the destination node. The node creation can be implemented by using the graph partition algorithm, and also you generate a node network with the help of the data encryption and send to the destination node. And if the data encryption sent to the destination node means we have to receive the source data packet, and data encryption, decryption, and get the original source node data, node analyze from the source to destination, and find the shortest path using the BFS. And this is the main architecture diagram of the partition our engine for the parallel graph computation. Thus, the main part of the architecture diagram is select the data from the different source and get encrypted and sent to the destination node, and receive source data packet, and it can be decrypted by the original source data, and the node can analyze the source from destination and get the shortest path using the VFS. This is the coding page of the page partition our engine for the parallel graph computation. In this program page, we have to first we run the home page, just like that, to run file. It is a home page of this page partition our engine for the parallel graph computation. In this page, you have to click the start buttons, click here to deploy the nodes. So if you click the OK button, just like that, sensor node deployment, just that on node 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It is a sensor node deployment. This deployment can connect with the other nodes. Just like that, you have select a send the source code. Just like that, it is a node 1, 2, 3, 4, 5, 6, 2, 11, 12, 13, 14. Just like that, you have to sender means enter the source code 2. Then you have to click the OK, and also your receiver node enter the destination node, receiver to OK. Source and destination are same, So you have to click align node with sensor nodes, x-axis, y-axis and paths. These are the sensor node 1 2 3 4 5 6 7 8 9 10 11. These are the x-axis, and also here y-axis, it is a y-axis can also be displayed under path. This is the path 13 is a location path. Then you have to package selection. Package selection means sender node selection node to select packet. Select file on the 3. Here source code, just like that, table code.txt and OK. Table code.txt and OK. You have to find enter the view information. This is the coding of this program code, and you have to encrypt the file just like that. Packet encryption, secret key, collect. You have to find the secret key is a collect, and you have to encrypt the data. This is the data of this encryption data. Means you have to encrypt means just like that. You have to put encrypted file encrypted successfully. This is the encrypted format. This is the encrypted format. Under that you have to packet splitting. Enter the file name to split. Just like enter the file name to split means file, and you have to click the schedule buttons. Enter the number of file 3, and files can be splitted. Files can be splitted as 3. Okay. Then you have to schedule the information. Enter the number of files can be splitted 3. Okay, and schedule information. Schedule information, node information. The total number of node deployed 14. Selected node source 2, and selected destination node is 2. And also your packet information. Name of the file chooses for splitting. File number of splitted is files 3. And display isomnet means table code.txt. Packet name, file name, it is an optimal path. That's the optimal path. This is the optimal path. Sender node, receiver node, and interval. Source node, forwarding interval, bandwidth, align node path. This is the path distance. This is the path distance of this cluster path can be activated, and also here cluster source node, forwarding interval, and bandwidth. What is the next? The align node, routing path, source code, and also here and data packet first. Choose 2. File 3 data has port number is 333. File 3, and also your port forward. File is waiting for receive. Destination, you have to enter the receiver port. Just like that, receiver port we have to secret code, just like that. 111 accept. This is arrange. Receive packet list, and receive the arrange list, and also your packet arranging. The packet is arranging decrypted data. Enter your source code is collect, and OK, decrypted successfully. This is the decrypted text form of this method, and also just like that, evolution. This is the packet delivery ratio and throughput and end-to-end delay. This is the packet delivery ratio, just like that. It is a packet delivery ratio, the PDR percentage rate, and also time. It is a difference EDF and the hierarchical, and also your throughput. It is the packet images throughputs and number of nodes, just like that. it is an end-to-end delay, average end-to-end delay, delay in time and traffic loads, pay packets. Thank you.